Hey guys, so today I'm going to be explaining to you how to answer question 2 of the ECON3123 problem set, specifically problem set 1. Even more specifically, we're only going to be answering parts A and B right now. I'm not going to read the whole question to you because it's pretty long, but I just want to highlight some key facts. So the things that we absolutely must know is the utility function of the principal, which over there is x1 plus x2 minus w, and the utility function of the agent, which is w minus half outside of E1 squared plus E2 squared minus E1 E2, which means it's a crowding in effect. Another thing that's important is that the wage, W, is equal to alpha plus beta Y, where Y is equal to X1 only, which means that the agent will only be paid for his output in task 1, although the principal gains utility from output in task 1 and 2. So we'll see how that will resolve that. I guess the final thing we should know is that x1 equals E1 and x2 equals E2. So the principal, the output is equal to the agent's effort in each task. We're only going to be doing parts A, which is the agent's maximization problem, and part B, which is the principal's payoff maximizing function. All right, so let's get right into it.
All right, so the first thing we should do is write down what we actually know. So we know that the utility of the principal is equal to the output of the first task plus the output of the second task minus the wage paid out to the agent. We also know that the output for each task is equal to the effort that the agent puts in, the effort levels. All right. We also know that the wage has a fixed incentive as well as a percentage of the, not the output, but the thing that we can measure, the performance measure, which actually just turns out is just the output from the first task, okay? And finally, we know that the utility of the agent is equal to his wage minus half effort for both tasks squared individually minus E1 E2. Now this minus means it increases his utility as he puts effort into either task, which means that this is a crowding in effect. So putting effort into one task will help, will give him more utility. All right, so next we want to find the agent's maximization problem. So let me push this up to here. All right, so to do that, we need to find the derivative according to what of the agent's utility according to what he can control, which is E1 and E2. As you saw before, the three steps, the four steps were that 1, the principal offers a wage. 2, the agent accepts or rejects. 3, the agent chooses what effort level he'll put in. And 4, the principal pays the agent. So we're going to be using backwards induction. So 4, the principal pays the agent. We assume that's the case, okay? 3, we want to see what effort levels the agent is going to put in to maximize his utilities. So the first thing we're going to do actually is substitute what W is in here. So we can put it all into things that the agent can affect. So we're going to put it into terms of, we're going to find his utility in terms of E1 and E2. So remember his wage is alpha plus beta Y minus, and I'm just going to expand this out now. As you can see, the minus and the plus makes a minus, and the minus will become a plus. Oops, that should be plus half E1, E2. All right, now I'm gonna this by can be substituted by y equals x1, which is also E1. So we're just gonna go ahead and put those two steps together to make it equals alpha plus beta E1 minus half E1 squared minus half E2 squared plus half E1 E2. Now we're ready for the first order conditions. So what I'm going to do is get rid of something. Okay, so now this is UA in terms of E1 and E2. So now we're going to find the first order conditions. dUA over dE1 first equals this here will just become beta. This will be minus E1, the squared and the half cancels out. This isn't used, or this is used, this isn't used, and this is used as well, which will become plus half E2 equals 0. You need to set it to 0 to find out what E1 is going to be. And that means that E1 is going to equal, if you just bring it to that side, beta plus half E2. All right, we're not done yet. So I'm just resetting the whiteboard. Let's see what we had. So we had UA was equal to alpha plus beta E1 minus half E1 squared minus half E2 squared plus half E1 E2. And we found out that E1 was equal to beta 1 plus half E2. All right, so that's what we found before. Now we're going to find first order conditions. We're going to find E2. So dUA over dE2 equals, whoops, not this one. God, this is going to be a long video. Sorry about this. This becomes negative E2, and this simply becomes plus half E1, and you set to 0. And this leads us to E2 equals half E1, because you just brought the E2 there. Now, we're not done yet, so let's find them all separately. So we know E2 equals half E1, and E1 equals B1 plus half E2. Okay, so these are our two equations. All right, now we're going to sub E2 into E1 to find E1 purely in terms of beta. Okay, so E1 will equal beta 1 plus half times half E1, because I've substituted E2 into here. Half E1 equals beta plus 1/4 E1. Now we're going to bring this to that side, so it's going to become 3/4 E1 equals beta, and so dividing both sides by 3/4 will give the effort level for E1 is going to be 4/3 beta. So we're back with a clear whiteboard. What we know is that E1 star equals 4/3 beta. So this is the optimum level of effort that the agent can put into task 1. And we also knew that E2 was equal to half E1. So what we're going to do is just sub this in here to find the optimum level that of effort that it should be put into E2. And we're going to find that E2 equals half times 4/3 beta. Therefore, E2 star equals 4 on 3/6, it will be 2/3 beta. Okay, so just to finalize the answers, therefore, E1 star equals 4/3 beta, and E2 star equals 2/3 beta. So this is the optimum level. This is the effort levels that the agent should put into task 1 and task 2 to get his to maximize his utility. All right, welcome back to a clear whiteboard. And what we're going to do now is question 2b, which is the principal's maximization problem. So the principal we saw before, his utility was, let me just look at it quickly. It was x1 plus x2 minus w. And the agent's utility was w minus half e1 squared minus half e2 squared plus half e1 e2. All right, so now since the principal, let me write the wage down as well. Alpha plus beta y, where y equals x1, which equals e1, and x2 equals E2. I'm just going to write that too. All right, we know this now. Now, since the wage includes a fixed part, the principal is actually going to incentivize the agent, well, what we expect, by giving him, well, we expect all of the output, and then he's going to extract all that utility through this alpha, this fixed payment, which we expect to be negative. So what that means is basically the agent is going to have to pay the principal to work. But he's going to have to pay the principal to work. So the principal is going to make sure that the agent accepts the offer, because we found from backwards induction, step 3, the effort levels that he's going to put in. Now, for step 2, which was the agent accepts or rejects the incentive, the agent has to get at least his outside utility so that he can work. So the agent's outside utility is actually 0 in this case. But either way, the principal, to extract all the surplus he can, is going to set alpha such that the agent gets his outside utility of 0. Now, the way he can do that is by acting like the planner. So this is the planner's utility, but it will also equal the utility of the principal, because if you do this little trick, so what I've done here is, since the principal is going to make UA equal to UO to maximize his utility, that means that UA minus UO is going to equal 0. 0. Which means if that's 0, then UP equals UP. Perfect. So let's write UP in terms of alpha and beta, because then we can differentiate and use first order conditions to find out the optimal alpha and beta. All right, so the first way we're going to write it out is UP equals x1 plus x2 minus W plus W minus, I don't think we're going to have enough space, so I'm just going to write it this way again, minus E1, E2. All right, we've got enough space. I think it's going to do all that. Anyway, so then you can see here that the wages actually cancel out, because the planner doesn't care about the wage, he just cares about the optimal effort levels. He doesn't need to incentivize anyone. So that means that, and since it's the utility of the principal is going to become x1 plus x2 minus half E1 squared minus half E2 squared plus half E1 E2. Okay, all right, so back with the clean whiteboard. And what we found out is that the utility of the principal can be written as x1 plus x2 minus half E1 squared minus half E2 squared plus half E1 E2. Now, what are we going to sub in? We're going to sub in x1 equals E1 star. From before, we knew that. And from part A, we found that this was 4 on 3 beta. We're also going to sub in x2 equals E2 star, which we knew from before. And what we found from part A was that equals 2/3 beta. Okay, so we're going to sub these two into this longer equation. So that means UP will equal 4 on 3 beta plus 2 on 3 beta minus half 4 on 3 beta squared. Is it going to fit? I'm just going to write it down here. Sorry. Minus half 2 1/3 beta squared plus half 4 on 3 beta 2 on 3 beta. So what we just did was sub in these into here and get it here. Now we'll expand it. All right. Therefore, the utility of the principal becomes 4 on 3 beta plus 2 on 3 beta minus 8 on 9 beta squared plus 4 on 9 beta squared. did I say plus 4 on 9 beta squared? I meant minus 2 on 9 beta squared, and then there's a plus 4 on 9 beta squared. So this became that, that became that, this became this became this, and this became that. Alright, so now simplifying this, we're going to get 4 on 3 beta plus 2 on 3 beta is 6 on 3, so 2 beta, minus 8 on 9, minus 2 on 9, minus 10 on 9, plus 4 on 9 will give minus 6 on 9, which is 2/3, so minus 2 on 3 beta squared. Okay, now we've got the utility of the principal only in terms of beta, which is good because that's what he can control. Now to find the optimal beta, we're going to use the first order conditions and find the derivative in terms of beta. So we'll equal 2 minus 4 on 3 beta set to 0. Now solving this gives 4 on 3 beta equals 2. We've just put it here. And therefore, that means beta star. So the optimal beta, the incentive that the principal will pay to the agent, is going to be 3 on 2. Okay, so we found that beta equals 3 on 2. That's great, but we still have to find in the wage the alpha. Okay, so remember, the principal is going to extract all the utility through alpha. So he wants to set alpha such that the utility of the agent is equal to his outside utility. So he'll be indifferent between working and not working, so the principal can get all that surplus. And we know from the question that that equals 0. So now what we're going to do is find UA, like we're going to write down UA and then equal it to 0 by changing alpha. So UA equals the W, which is alpha, plus beta, Y, which is X1, which is E1. And we're just going to quickly write his cost of work function, cost of effort function, half E1, E2. Okay, perfect. And now remember this equals 0, but what we're going to do is sub in the effort levels we found before, the optimal effort levels and the optimum beta. Okay, so it's going to become alpha plus beta star, remember, was 3 on 2. E1 was 4 on 3 beta, beta's 3 on 2, okay, minus half outside of E1 was 4 on 3 beta, so 4 on 3 times beta, which was 3 on 2. We're going to square that. Now I'm just going to come down here so we don't run out of space. Minus half. E2 squared was 2/3 beta. And remember beta, 3 on 2. We're going to square that. Plus half. E1 was 4 on 3 beta, which was 3 on 2. Times E2, which was 2 on 3 beta. Times beta, which was 3 on 2. Alright. We're back with a clear whiteboard. Sorry if it looks slightly different to where it was before. My camera actually died after the last calculation we made, so I had to quickly fix that. And yeah, so we're back. So what we last found out was that UA equaled alpha plus a certain sum, which we calculated, well, which I calculated behind the scenes to be 3 on 2. Now remember, we need to make it, well, the principal wants to make sure that it equals the outside utility to make sure he gets all the utility, or he extracts all the surplus. And we know from the question that that equals 0. So we get alpha plus 3 on 2 equals 0. Therefore, our alpha, our best alpha for the principal to extract all the surplus, or the maximum surplus he can, is negative 3 on 2. And we put that together with the maximum bonus incentive, which was, sorry, one sec. And we put that with the maximum bonus incentive, well, to maximize the principal's utility, which was 3 on 2. And these are the incentives, the fixed incentive and the bonus incentive, that the principal will pay the agent to maximize the principal's utility. So the answers were, for 2A, the agent will put in 4 on 3 beta into this task, and E2 is 2 on 3 beta star, which if we sub in our 3 on 2, we will get, this will induce an effort level of 2, because 4 on 3 times 3 on 2, cross out 3, 4 on 2, yep. And for this, it'll be 3 on 2, 2 on 3 equals 1. So these are the effort levels that the agent will put in, although this is really the answer to maximize the agent's utility. And then for the principal, the answer is negative 3 on 2 for the fixed principal, and 3 on 2. Okay, these are your answers. You've answered the question. Thanks for watching.